Hi guys, in this video we are going to learn how to solve quadratic equations. Before we start, please subscribe to our channel and don't forget to click the bell button to turn on notifications. Okay, let's get started. Quadratic equations are equations with one variable and the highest exponent of the variable is 2. Its standard form looks like ax squared plus bx plus c equals 0. Here, x is the variable. A, b, and c are known values. A cannot be 0. Now let's talk about solving quadratic equations. For some quadratic equations, we can solve them by factoring, which sounds familiar, right? If you forgot how to factor polynumerals, we've posted some links in this video's description for you to practice. Let's try the first example by factoring out the greatest common factors. 3x squared plus 12x equals 0. The left side of the equation is a polynumeral. Both terms have a common factor, 3x. So we factor 3x out and get 3x times parentheses x plus 4 parentheses equals 0. We already know when the product of two terms is 0, then at least one of them should be 0. Here, the equation equals 0, so x or x plus 4 should be 0. And we get the solution x equals 0 or x equals negative 4. We usually call the solution of quadratic equations roots. Here, the roots are x equals 0 or x equals negative 4. By factoring out the common factor, the quadratic equation becomes the product of two simple linear equations. In this way, the quadratic equation is simplified and it is easier to find the solution. It's cool, right? Let's look at the second example. 4x squared minus 9 equals 0. Here, 4x squared is the square of 2x. And 9 is the square of 3. So we can use the square difference formula to factor the left side of the equation and get parentheses 2x plus 3 times parentheses 2x minus 3 equals 0. As we just learned, when 2x plus 3 equals 0 or 2x minus 3 equals 0, the equation equals to 0. So we just need to solve these two simple linear equations to get the solution. In the equation, 2x plus 3 equals 0. Move 3 to the other side and change the sign, and we get 2x equals negative 3. Now divide by 2 on both sides to get x equals negative 3 over 2. In the equation, 2x minus 3 equals 0, move minus 3 to the other side and change the sign to get 2x equals 3. Divide by 2 on both sides and get x equals 3 over 2. So the equation has two roots, x equals negative 3 over 2 or x equals 3 over 2. Now, did you remember that we can use the perfect square formula to factor polynumerals? That is a squared plus or minus 2ab plus b squared equals parentheses a plus or minus b parentheses squared. It can also be applied to solving equations. Let's try this method together. X squared plus 10x plus 25 equals 0. Here, 25 is the square of 5. 10x equals 2 times 5 times x. So, the perfect square formula can be used and the equation turns into parentheses x plus 5 squared equals 0. Only when x plus 5 equals 0 will the equation be equal to 0. As a result, we get x equals negative 5. This equation has only one root, which is x equals negative 5. Now, can you guess which other factoring methods can solve the equation as well? Yes, the answer is the crossing method, also called the FOIL method. Let's try solving an equation together in this way. 3x squared plus 5x minus 28 equals 0. Here, 28 can be the product of 1 and negative 28, negative 1 and 28, 2 and negative 14, negative 2 and 14, 4 and negative 7, or negative 4 and 7. Let's cross multiply them with x and 3x. As we can see, only the pairs 4 and negative 7 will bring us 5x. So the equation can be factored out into parentheses x plus 4 times parentheses 3x minus 7 equals 0. When x plus 4 equals 0 or 3x minus 7 equals 0, the equation equals 0. Solving these two simple linear equations will get the two roots, x equals negative 4 or x equals 7 over 3. What if quadratic equations can't be factored out? There is a method called completing the square. Let's do some exercises to understand how it works. X squared plus 6x minus 1 equals 0. The left side is not the square of anything, but thinking of the perfect square formula, a squared plus 2ab plus b squared equals parentheses a plus b squared. Here, a equals x and 2b equals 6, which means that b equals 3. So in this way, we just need to add 9 to complete the square of x plus 3, and then subtract 9 to keep the value on the left side unchanged. So we get x squared plus 6x plus 9 minus 1 equals 0. X squared plus 6x plus 9 is the square of x plus 3, and the equation turns into parentheses x plus 3 squared minus 9 minus 1 equals 0. We move the numbers to the right by changing their signs. If you're not familiar with this transposition method, check the link on the top right of the video. Let's continue and get parentheses x plus 3 squared equals 10. Taking the square root on both sides, we get x plus 3 equals plus or minus the square root of 10. So now, x plus 3 equals the square root of 10, or x plus 3 equals the negative square root of 10. Now the solution is x equals the square root of 10 minus 3, or x equals the negative square root of 10 minus 3. Now you're done. Let's look at another example. X squared minus 10x plus 7 equals 0. Here, half of 10 is 5. 5 squared is 25. So we add and subtract 25 on the left side of the equation and get x squared minus 10x plus 25 minus 25 plus 7 equals 0. X squared minus 10x plus 25 is the square of x minus 5. So the equation turns into parentheses x minus 5 squared minus 25 plus 7 equals 0. The next step is to move all the numbers to the right side by changing their signs to get parentheses x minus 5 squared equals 25 minus 7 equals 18. Take the square root on both sides and get the two linear equations. X minus 5 equals the square root of 18, or x minus 5 equals the negative square root of 18. The square root of 18 is the square root of 9 times 2, or the square root of 3 squared times 2. So that means x minus 5 equals 3 to the square root of 2, or x minus 5 equals negative 3 square root of 2. So the solution is x equals 3 to the square root of 2 plus 5, or x equals negative 3 to the square root of 2 plus 5. In the previous examples, we can see that the coefficients of x squared are 1, and the coefficients of x are even numbers. The completing the square method is the most helpful in this situation. But what if the equation looks like 3x squared minus 11x plus 7 equals 0. It's a little bit different, but if we use the completing the square method to solve this equation, we have to divide the coefficient of x, in this case 3, on both sides. Now we can see that the coefficient of x in the term of the number negative 11 over 3 and 7 over 3 are fractions now. That means that the calculation in the next step will be much more complicated than in the previous examples. To solve this kind of messy equation, a formula called the quadratic formula can always be applied. It's the general formula to solve all quadratic equations. The formula is ax squared plus bx plus c equals 0. Its solution, the value of x, are given by x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Although the formula looks long, I highly recommend that you memorize and know how to prove it. Knowing how it works will help you remember it. Now I will show you how to prove it using the completing the square method. We already know that the general form of quadratic equations is ax squared plus bx plus c equals 0. To solve this problem, we need to complete the square, but if we divide all the terms by a and turn the coefficient of x squared into 1, the coefficient of x and the item of the number become fractions. As I just said, the calculation will be much more complicated, so we need a trick. First, let's multiply 4a on all the terms. 4a times ax squared plus bx plus c equals 0. Removing the parentheses, we get 4a squared times x squared plus 4abx plus 4ac equals 0. 4a squared times x squared equals parentheses 2ax squared. 4abx equals 2 times 2ax times b. So we just need to add b squared to complete the square of 2ax plus b. To do this, we just need to add and subtract b squared at the same times, which becomes the complete square, parentheses 2ax plus b squared minus b squared plus 4ac equals 0. Move 4ac to the right side by changing their sign to get parentheses 2ax plus b squared equals b squared minus 4ac. Take the square root on both sides and get 2ax plus b equals plus or minus the square root of b squared minus 4ac. Move b to the right side and change its sign to become 2ax equals negative b plus or minus the square root of b squared minus 4ac. Divide 2a on both sides to get x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Now we're done. That's the proof. We talked about the quadratic formula. Remember, it's the general formula to solve all quadratic equations, and the formula is ax squared plus bx plus c equals 0. Its solution, the value of x, are given by x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. It looks complicated, but it's very important, so I highly recommend that you memorize it. If you want an easier way to remember it, just follow along as I explain this short story problem, and then you'll get it. A negative boy was debating whether or not he should go to the party. At the party, he talked to a square boy, but not to the 4 awesome chicks. The party ended at 2 a.m. It really helps, right? Now let's try to solve an equation by the quadratic formula together. X squared minus 3x plus 1 equals 0. Here, a equals 1, b equals negative 3, and c equals 1. So we can get the solution directly by plugging all the numbers in and getting x equals negative times negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 divided by 2 times 1. The equation can be simplified as x equals 3 plus or minus the square root of 9 minus 4 divided by 2 equals 3 plus or minus the square root of 5 divided by 2. That means that this equation has two roots. X equals 3 plus the square root of 5 divided by 2, or x equals 3 minus the square root of 5 divided by 2. If it seems difficult to solve the equation with factoring or completing the square method, just use the quadratic formula directly and you'll get the solution. Quadratic equations can be applied frequently in the world, so let's look at some examples together. Okay. The area of a storage room is 24 feet squared. It's a rectangle and its length is 5 feet more than its width. What are the lengths and widths of it? First, let's assume that the width is x. Then the length has to be x plus 5. Because the area is the product of the length and the width, we can make the equation. It's x times x plus 5 equals 24. Multiplying out the parentheses, we get x squared plus 5x equals 24. Now just move 24 to the left side and change the sign and get x squared plus 5x minus 24 equals 0. If you're not familiar with this transposition method, check the link in the video's description to learn more. But let's continue with the story problem. By using the crossing method, we can easily get the solution 24 is the product of negative 3 and 8, because negative 3x plus 8x equals 5x, so we can get parentheses x minus 3 times parentheses x plus 8 equals 0. Then we get the two roots x equals 3 or x equals negative 8. But is this the final solution? No, because they already mentioned that in the problem x must be positive. So x equals 3 is the only solution of this problem, and the length is x plus 5 equals 8, so you're all done. Check the link in the video's description about crossing method if you're not familiar with it. But don't worry if you really don't want to use the crossing method, because there is ways to get the solution with the quadratic formula directly. Here's how. After we make the equation x squared plus 5x minus 24 equals 0, we can see a equals 1, b equals 5, and c equals negative 24. So x equals negative 5 plus or minus the square root of 5 squared minus 4 times 1 times negative 24 divided by 2 times 1. This can be simplified into x equals negative 5 plus or minus the square root of 25 plus 96 divided by 2. Then x equals negative 5 plus or minus the square root of 121 divided by 2. 121 is the square of 11, so we get x equals negative 5 plus or minus 11 divided by 2. X equals 3, or x equals negative 8. X must be positive, so x can only be 3. The quadratic formula seems sometimes more difficult than the crossing method, but you don't need another method. Just remember the formula and you'll get the right solution. Okay, let's look at another example. A shop can sell 20 t-shirts a day on average. The profit of selling one shirt is $40. A research shows that every $1 decrease in the price, 2 more shirts can be sold. The goal of the shop owner is to have a profit of $1,200 in one day. How much should the price be reduced to reach the profit? First, we assume the profit should be reduced by X dollars. Then, 2x more shirts will be sold. The total amount of shirts sold will be 20 plus 2x. The profit of selling one shirt will be decreased to 40 minus X dollars. Thus we get the total profit as parentheses 40 minus X times parentheses 20 plus 2x. As we already know, in the problem, the total profit should be $1,200. So we can get the equation parentheses 40 minus X times parentheses 20 plus 2x equals 1,200. Simplify the equation by multiplying the parentheses out. 40 times parentheses 20 plus 2x minus x times parentheses 20 plus 2x equals 800 plus 80x minus 20x minus 2x squared equals 1200. 80x minus 20x equals 60x. Then move 1200 to the left side by changing its sign. So we get 800 minus 1200 plus 60x minus 2x squared equals 0. Then negative 2x squared plus 60x minus 400 equals 0. Divide all terms by negative 2 and the value will not change, so the equation turns into x squared minus 30x plus 200 equals 0. The coefficient of x squared is 1, and the coefficient of x is an even number, so we can try completing the square by solving this equation. If you're not familiar with this completing the square, check the link in the video's description to warm up. Okay, let's try it. First we add and subtract parentheses 30 over 2 squared to get 15 squared on the left side of the equation and get x squared minus 30x plus 15 squared minus 15 squared plus 200 equals 0. The square of 15 is 225, so we get parentheses x minus 15 squared minus 225 plus 200 equals 0. Moving the numbers to the right side and changing their signs to get parentheses x minus 15 squared equals 225 minus 200 equals 25. Take the square root on both sides and get x minus 15 equals 5 or x minus 15 equals negative 5. The solutions are x equals 20 or x equals 10. That means the profit of $1,200 can be reached when the price is reduced by $10 or $20. In another example, you certainly can solve the equation with the quadratic formula. In the equation, x squared minus 30x plus 200 equals 0, a equals 1, and b equals negative 30, and c equals 200. So x equals negative to negative 30 plus or minus the square root of negative 30 squared minus 4 times 1 times 200 divided by 2 times 1. Then x equals 30 plus or minus the square root of 900 minus 800 divided by 2 equals 30 plus or minus the square root of 100 divided by 2. 100 is the square of 10, so x equals 30 plus or minus 10 divided by 2. The solutions are x equals 20 or x equals 10. That's it. I think we've already learned enough for today. In the next video, we will talk about the quadratic function, which is based on the quadratic equation, so please stay tuned. If you have any questions, leave a comment below or email us at question@beat-math.com. We will try to answer your questions in a future video, and the most common question will be given priority in our next video. See you next time!